Now see here electric dipole. What is electric dipole actually? So you might have seen like the molecules, HCl molecules, where HCl or you take HCl here, H plus Cl minus, this is an example of electric dipole. So electric dipole is actually a pair of two equal in magnitude but opposite in nature, so charges, and which are separated by a small distance. Suppose you have taken here charge plus Q and here is charge minus Q, which are separated by a small distance, suppose 2a. So this pair of the two charges, Q and minus Q, having equal magnitude but opposite sign, separated by a small distance, is known as electric dipole. And see here the net charge of this electric dipole is 0. And here we define electric dipole moment. Electric dipole moment is P is equal to magnitude of the either charge into 2a. So the electric dipole moment of this system is actually defined as the product of the magnitude of the either charge and the distance of separation. Electric dipole moment is a vector quantity. By convention, its direction is taken from negative to positive. So direction of electric dipole moment is like this, that is negative to positive. And see here, SI unit of this electric dipole moment is here Coulomb into meter. You can write from here only this is Coulomb and 2a is the distance of separation, that is here Coulomb into meter. The dipole has got this line is known as axis of the dipole. And this perpendicular bisector of this axis is known as equatorial line of the dipole. So now we have to calculate electric field intensity at a point on the axis of the dipole and also at a point on the equatorial line of the dipole. Now here we have to calculate electric field intensity on axial line of dipole. Suppose we have taken this is charge here minus Q and here is plus Q. And this is here the axis of the dipole. This is the distance of separation, this is 2a, that is the center of the dipole. If we want to calculate electric field intensity at this point P, which is located at a distance r from the center of the dipole. So we can take electric field intensity at point P due to these two charges, one is by negative and one is by positive. So we assume here unit positive charge. So due to negative electric field intensity will be here E minus Q due to negative charge, and due to positive charge we will be getting this side, that is E plus Q. So here we can write electric field intensity, that is a magnitude of this is E plus Q, is equal to Q upon 4 pi epsilon naught. Distance from here to here is, R minus A, because this is A, this is A. So due to plus Q we need this distance, so that is R minus A whole square. Electric field magnitude of this minus Q is equal to, can be written here, Q upon 4 pi epsilon naught R plus A square. This is from here to here. Net electric field intensity we can write E is equal to E plus Q plus E minus Q. And here, now we can write here, we can get the net electric field. E is equal to Q upon 4 pi epsilon naught R minus A square. Here we write P cap. We take unit vector whose direction is from negative to positive. So P cap plus Q upon 4 pi epsilon naught R plus A square, that is here minus P cap, that is positive to negative. So negative to positive we have taken P cap, so obviously to this side we have taken here minus P cap. So now we can solve and get the net electric field.